Good evening, Kellyville. That's a movie reference if you didn't know. In this video, we're going to talk about matrix multiplication, and I can't describe how much of the tip of the iceberg we are looking at here. All right, we're gonna breeze over so much here. All right, I don't have time really to talk about everything, but there is going to be a separate video where I talk about like the applications of matrices and the dot product, a little bit more about that. Watch that. I do encourage you to watch it. It's not required though. It's not one of our mandatory videos. All right. So before we can multiply matrices, we're going to talk about how to find the dot product because they are related. So the dot product is a way of taking like two sequences of numbers. Notice here they're equal in length. That has to be true. In order to do the dot product, the lengths have to be the same. What we're going to do is we're going to multiply the corresponding pieces. So like 4 times negative 2 is negative 8. 8 and negative 5 is negative 40. 2 and 2 are 4. And then we're also going to be plussing them. We're going to be adding those corresponding pieces. So plus, plus. All right, negative 48 plus 4, that's negative 44. Okay, and that is the dot product of these two, we'll call them matrices, but we're really thinking of them as these other things called vectors. And in that other video, I'll talk about vectors and dot products a little bit deeper. Anyway, here we go. Matrix multiplication. These are both 2 by 2 matrices. It's got 2 rows, and they each have 2 columns. All right. Now to multiply them, what we're going to be doing is we're going to be doing that dot product thing. We're going to be doing it twice. The way it works is whatever your first matrix is, you're going to take the rows from this one, so 8 and 4, and you're going to multiply that, the dot product, by the columns of your other matrix. So we're going to be doing the dot product of 8, 4, and negative 2 and 4. All right. Anyway, this answer, this is pretty simple. I think you'll be able to catch on pretty easily. These are going to be simpler matrices. For the larger ones, we're going to use a calculator. So here I go. I'm going to take this row, so row 1, and over here, column 1, and that's going to give me this position right here. Notice this is row 1, column 1 in our answer. So I'm going to do 8 and negative 2. That's negative 16 plus 4 and 4. All right, and that's equal to 0. I guess I could just leave it like that. I'll put a 0 there. All right, and now I'm going to use, to figure out the next one, I could either go here or here or here, but it really depends on the row you do here and the column you pick over here. I usually stick with the first row, and then I just do all the columns. So I'm going to do row 1, but this time I'm going to do column 2. All right. So 8 and negative 3 correspond. That's negative 24. And 4 and 5 correspond. So that's 20. And you're going to get negative 4 when you add those up. Okay, let's do the next one here. We're going to move on here to our second row. And we're going to go back to the first column. So negative 3 and negative 2, that makes 6. And 1 and 4, that makes 4. So notice that's going to give us our row 2, column 1 answer over here. That's 6 plus 4, 10. All right, last one to do is row 2, column 2. That's going to give us row 2, column 2. So you're going to get positive 9, positive 5, so positive 14. And that's our answer. So matrix multiplication, it does do something, right? It actually has applications. It's not just, me making it up and having fun, although I do kind of enjoy it. Anyway, so yeah, please check out that other video. All right, I didn't just make it for my health. I've basically borrowed from everything I could learn from YouTube to learn what matrix multiplication does, and it's really cool. Here we go. We're going to do another example. Oh yeah, I need to point out, if you reverse these, all right, if you were to put this matrix first on the left side, you would not get the same answer, okay? There's a homework problem that tells you to do something like that. So you're going to have to do it both ways. You will not get the same answer if you flip these two matrices. All right, we'll do another one here. Row 1, column 1. So we get 6 for 3 in the 2. And then we get positive 1 there. So that gives us 7. Now let's do row 1, but column 2 this time. All right. I don't know why I did that. It looks weird. So focus on this column here. All right, we get 3 and 1. That makes 3. Plus negative 1 and 3. That makes negative 3. So you get 0. We'll mark that one out. We'll do the second row here. First column. So row, column, row, column. You're going to get positive 2 for that one. And you're going to get negative 2 for that one. Okay. Positive 2 and negative 2. That's weird. You get another 0 here. Interesting. And then we're going to do row 2, column 2 to end it out right here. You're going to get positive 1, and you're going to get positive 6, and that's equal to 7. So you get this kind of a symmetry going on here. 7s in the corners and 0s elsewhere. Actually, I did this example on purpose. I want to show you something. If you, I don't know if this is the right word for it, but if you factor out a 7 from this matrix, I'm waving my hand here, but I'm going to put a 7 on the outside. It's kind of like the reverse distributive property. If you distributed the 7 in, you'd get 7 times 0 is 0, 7 times 1 is 7, and then likewise over here. This matrix, no, not that one. This matrix, this little 2 by 2 matrix is very special. This is called the 2 by 2 identity matrix. So not the 7, it has nothing to do with that. That 7 just happens to be here. So this was our answer, but I want to point something out about this. If you were to take this identity matrix and multiply it by some matrix, whether you did it on the left side or the right side, your answer would always be the other matrix. All right. This matrix doesn't change anything. All right. It has uses kind of like, you know how, what's a good example here? We have identities in regular numbers. 0 is the additive identity. 1 is the multiplicative identity. Oh yeah, that's how we use it. If you were solving 3x equals 6, you would divide by 3 so that you get the multiplicative identity right here. It's the same concept. Anyway, hand wavy. Hope you learned how to do the rows and columns. That was the goal.